Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
So welcome everybody and thanks for joining us today. As Lindsay said, my name is Scott Hansen and I am one of the technical service managers at Reliable. And at Reliable, as you know, we're celebrating our 100-year anniversary this year, and we've been making sprinklers and valves that whole time. So today's presentation, we're going to talk about, the air supplies, and we make dry and pre-action systems, and those systems require supervisory air pressure, and that supervisory air pressure needs to meet the minimum requirements in the NFPA standards. And just to clarify, if any of you know me, and if you don't know me, I am not going to get into the nuts and bolts of the compressors or switches. All right, my goal today is to I'm going to say dumb it down so I can understand it. And hopefully that means you will all understand it better than me. But my goal, honestly, is to come across from a sprinkler guy's viewpoint. So just moving right on into the presentation, the question comes up, why this topic? And quite honestly, it all started with a phone call a long time ago. Seems like a long time ago anyway. Customer calls up on our tech line, and we get a lot of calls every week about air supplies, compressors, and switches. Got a problem setting up a dry valve. We ask questions, we answer questions, and ultimately ask the question, what kind of an air compressor are you using? And the answer came back was, let me see, a silver one. All right. It was quite shocking at the time, but it's kind of funny now. But the moral of that story is that we all need to understand. And I'm talking, when I say we, I'm not talking about just me and you, I'm talking about the industry. We all need to understand what we're installing and why. So hopefully that's where my goals come in and we hit that mark. So we're going to talk about the NFPA, and that's going to cover, and I referenced, all my references today are from the 2019 edition of NFPA 13, and then we also touch on NFPA 72 a little bit. And I'm hopefully going to break it down to, it's one thing to read the text, but I want to break it down so hopefully we understand what it really means. And then we're going to get into the switches, and both the alarm and supervisory switches. And heavy sigh, I'm a sprinkler guy. Why do I want to know about the electrical part? That's the electrician and the alarm guy's problems. Well, trust me, in reality, you need to know what's going on with the switches because you're the sprinkler guy, and in the middle of the night on a holiday weekend, you're getting that phone call, the electrician is not. And then intermixed between all this, we're going to talk about what we like to consider some best practices from a sprinkler standpoint. So moving on, jumping right into the meat and potatoes of our lives, NFPA 13 and air supply, air pressure and supply. And I'm not going to read all this text to you. What I want to do is I'm going to highlight some stuff that I think is important, and just kind of cover that. So, it seems simple, but sometimes that's the best way to do it. When you talk about air, what does that mean? That's the air we're breathing, right? That's the air we're putting in the systems. And NFPA went so far as to clarify that when we talk about air in NFPA 13, we mean air, nitrogen, or any other approved gas that you can use for supervisory pressure. All right, next section, maintenance of air pressure shall be maintained on dry pipe systems throughout the year, period. In the behind the scenes, if you guys are familiar with the handbooks especially, you'll see commentary in there from the experts. And what the intent of this section is basically to prevent you from turning a dry system wet. Let's say for the summer, and then forgetting to change it back to the dry system before the freezing cold hits, and you've got a sprinkler system popsicle and endless service calls and angry customers. You don't want that. So basically, you've got to leave if you've got a dry system, you've got to leave it a dry system all year round. All right, So air supply in general, once again, the highlights, shall be from a reliable source or from a source available at all times. Now, why do you think we would need that air supply source available at all times? If you look at my little examples on the top, you look at the balloon on the right-hand side. We just got done pumping it up, huh? Goes with the theme of the presentation, right? You leave the job site, all right? None of us, all of us sprinkler guys out in the world, we do not install leaks, but our systems leak. They just breathe, they leak, just little bits here and there. We get thermal expansion and contraction throughout the day, throughout the week, throughout the year. If you do not have an air supply that is there all the time to keep that system maintained, you're going to end up with a system that looks like the balloon on the left. It's going to be flat over time. All right, we all know what happens when a dry system loses air pressure, right? We get false trips. So simply put, when we look at that, the compressor stays on the job site. It doesn't go in the pickup and it doesn't go to the next job site, so you can fill that system up. All right, next one, 30-minute fill time. You know, the intent of that is if you've got a system up and running and you have to take that system out of service, that system is down and the building's not protected. All right, in order to basically limit the amount of time it takes to fill that system with air, NFPA drew a line and said 30 minutes. You get 30 minutes to fill that system. Your compressor, your supply has to be able to do that. And the only exception to that is for refrigerated spaces, which, you know, 5 degrees is the cutoff for Fahrenheit. So I would actually call that a freezer space, but refrigerated is good. And then when we're doing this fill time, you can manifold all these systems together, but the air compressor only has to fill the largest system. All right, so you can fill your systems one at a time, but the largest one has to be filled within 30 minutes, and your smaller systems will fill quicker than that. All right, so let's size an air compressor. We got a system. We get this question a lot in our tech service group, and we get it from customers calling our salespeople. Hey, I need a dry system valve, and I need a control valve. I need a compressor. What size compressor do you need? Well, you guys figure it out. It's your system, right? All right. And we'll gladly help you anytime. You can call our tech service number. The contact information is going to be on the last slide. But the critical things you're going to need to do as a designer or as a contractor is you're going to need to know your system size and volume, all right? And then you're going to need to know which dry valve you want to put in there so you can determine, I'll say it that way, what pressure you want to maintain in the system. So in my example right here, I'm going to take a 400-gallon system, and I already decided I want to maintain supervisory pressure at 20 psi. All right, so the beauty of most air compressor manufacturers, we all provide sizing charts. So this is the sizing chart in one of our bulletins. And like I say, I've got a 400-gallon system, and I want to maintain that supervisory pressure at 20 psi. All right, I go down the column and I've got a 400-gallon system. I look right there in the top there. I've got 455 gallons maximum system capacity. I can go over to the left and I've got a tankless compressor. That was my goal in this one. And I can get by with a 3rd horsepower compressor. So looking at that, before we go on to the next slide, I want to point out that a lot of things that you know, you can do with low pressure systems. And on the bottom, you'll see low pressure systems can utilize smaller compressors, which in the long term, you know, can save you some money. Because if you look at what you can do with that same 3rd horsepower air compressor, if you just have a system that requires even less air pressure, you can almost double the system volume, or actually more than double it. And then, you know, if you go back to a conventional differential dry system where, you know, the industry, it's kind of just a generic 40 psi in my system, you know, that 3rd horsepower can only fill a 200-gallon system at max. So, all right, what else can we do to size air compressors? And I'm a math nerd, NFPA 13 nerd, self-proclaimed on that one. But let's look at my tankless compressor example here. And let's look at the performance curve. So if you can't find a graph or a table that's going to break down the system size, you can figure it out yourself with the performance curves from these compressors. And I'm planting a seed there with that 5.5 CFM line there on top, and we'll get to that in a few slides. But like I talked earlier on the last slide, I want to maintain 20 psi pressure in my system. So if I draw a vertical line up to that third, and you can see it's the blue line there, but I'm going to draw a line then horizontally over to the CFM side on the left there, and at 20 psi, this compressor I picked puts out 2.5 CFM a minute, cubic feet per minute. So then somebody out there is hoping, and it's okay if it's one of our sales guys, all right, but you know, hey, we're sprinkler guys, you wanted to know how big the system was. I'm talking gallons, and what the heck are these feet you're talking? And it's just something that you know, the air compressor industry uses cubic feet per minute. How much does a compressor put out? Sprinkler industry, we use gallons, so we have to do math. So we're going to do a little math lesson here. So if you look at it, there's 7.48 gallons per cubic foot. All right, so 7.5 gallons per cubic foot. If we take that 400-gallon system and we convert it to cubic feet, all right, we're going to divide the 400 by 7.5. Basically, the gallons cross out each other, and we end up with 53.5 cubic feet of volume in our system. All right, now we got 30 minutes to fill that. So I take that 53.5 cubic feet, divide it by 30 minutes. I need to provide an air compressor that puts out at least 7.8 cubic feet per minute at 20 psi. I look at the graph again, and I got 2.5 cubic feet per minute. I'm golden. This is a compressor that'll fit my system. All right, moving on. I think that's the last math problem we have to do. Air supply connections. All right. NFPA requires the minimum pipe size feeding air into your system be 1/2 inch. All right, no ifs, ands, or buts. That's a nominal size. So if you use a flexible connection, the internal diameter may be different than the internal diameter of a hard pipe system, but minimum is 1/2 inch pipe. The other thing that's required is you have to have a check valve on the air inlet. Now that can be like in the example here on the left-hand side, the air maintenance device has a built-in check valve, or on the left-hand side, we've got a check valve right on the trim for the air inlet on a dry valve. All right, something new in the 2019 edition. If it wasn't quite, maybe it wasn't clarified enough, but it was added in text in the 2019 edition. You've got to have a listed or approved shutoff valve on that air supply line. Now, once again, comes on the air maintenance device, or depending on the dry system valve you buy, it may have it on the trim. All right, moving on. Let's look at the relief valve requirement. You have to have an approved relief valve between the air supply and the shutoff valve. Now, if you look at the picture here, we've got the ideal setup on the right-hand side. We've got a dry valve. Feeding air into the dry valve is a listed pressure maintenance device. That's our shutoff valve in this case. And then going farther to the left, you've got a compressor, which is our air supply. So that relief valve has to be installed between the compressor, basically the air supply, and the shutoff valve. And most modern day compressors have their own pressure relief valve built onto the trims. So you don't have to add an extra one. Moving on. System pressure. All right, system air pressure, NFPA requires that you maintain that system air pressure per the manufacturer's instruction sheet. All right, if you don't have that, there's an alternative method to figure it out. You basically figure out the calculated trip pressure, and that can be a trial and error basis, or you know, if it's an old school differential valve or a modern day differential valve, you can take the differential of that valve and basically do a little more math and add 20 psi cushion on top of that, and that's your system pressure. But in the background there, you can see, you know, this is a table from our FX dry pipe valve, where we will have a maximum water pressure, because you need to know your maximum water pressure, and then we'll always have a recommended minimum and a recommended maximum air pressure so we gave you a little bit of a range to supply supervisory pressure there. All right, so you notice I got some different colors on the underlines here. So we're talking automatic air maintenance, and right up on top there in the gray area, because this is the only gray area in NFPA 13. I'm not sure about that, but anyway. It says, unless the requirements of 82662 are met. And I'm not going to talk about that right now. We're going to get to that in a few slides. All right, let's jump right to the red. All right, shall be from a dependable plant system. And we all know the shells and the shoulds. This is a shall from a dependable plant system. What does that mean? Well, really what that means is 24/7, 365, no nights, weekends, or holidays off. That plant air system has to be up and running all the time. I've experienced this where, hey, yeah, we got plant air. We use our air tools all the time. And then Friday night, they shut it down. Sunday morning, we get a phone call, the system tripped. Okay. That's why it has to be 24/7, 365. No ifs, ands, or buts. All right. So the alternative to that is an air compressor with a receiver. And I want to point out that this is the rule, not the exception. All right. What's the receiver? Why can't they just say tank? Well, that's really what it means, is the receiver is the storage tank. So tank mounted compressor. All right. And then in the green, shall utilize an air maintenance device specifically listed for that use. So air maintenance devices. And when we started looking at that, and we'll get to that in the next slide, but these are the components, so in a nutshell, when you've got that dedicated air compressor, unless you meet the requirements of 82662, like I say, we'll get to that. It's got to be a tank mounted compressor with a listed air maintenance device. All right, so moving on, let's look at that air maintenance device. And there's actually, what's a listed air maintenance device? And it's actually just a device, I'll say a set of valves, regulators, and piping that's designed to maintain and regulate the pressure in your sprinkler system. And we actually make two different types. A lot of guys do, but we have a mechanical one. This is our Model A right here. And then we also have another one called the Model B, and that's an electrical one. All right, and it controls the compressor start and stop. All right. The way a mechanical pressure maintenance device works is you take a tank mounted compressor, then you maintain that pressure in the tank higher than your system supervisory pressure. All right. Then you take that higher air pressure, feed it into the air maintenance device. It runs through the strainer and the regulator and a check valve, goes into your system at the desired system supervisory pressure. All right. So you take a higher pressure, regulate it down to the lower pressure. So when the system calls for air, that regulator will open up, allow more higher pressure in until it's satisfied, and then it closes back down. All right, moving on. Let's look at the perfect scenario. This is the ideal installation. All right, you've got a tank mounted compressor on the left, feeds a mechanical air maintenance device in the middle, and it feeds just a nice simple differential drive valve or a low pressure drive valve, doesn't matter, or Preaction system, but ideal setup. All right, and just keep in mind that the mechanical pressure maintenance devices need that tank mounted compressor to operate correctly. Okay, so let's look at this scenario. Can I do this? Got the same drive valve, same air maintenance device, but now I'm going to use a tankless compressor. Not so good installation. Is it wrong? I'm not going to tell you it's not wrong, because nothing says you can't do this. What I will tell you that it's going to cause you some heartburn over the long term. When you look at a tankless compressor, it doesn't have a constant steady pressure, okay? It's got a pressure that's going to vary from its cut-in point, basically where the compressor starts pumping air, until its cut-off point. All right, where it stops pumping air. And typically you'll find, depending on if you get a low pressure compressor or a standard compressor, you'll have a 5 or 10 psi differential between your start and stop points. And if you run that with this, you look at how the mechanical air maintenance device, one of the things that why it has to be listed, it has to be tested basically to prove that it's not gonna let air into the system too fast. So let's just take this scenario. We have a sprinkler operate on the dry system. All right. We have the regulator that opens up. It senses the drop in pressure on the system side. It opens up. There's no reserve air supply. Your tank now is 1 or 2 feet, a half-inch pipe. That air supply is depleted right away. The pressure switch on the tankless compressor starts the compressor. The compressor runs full blast, catches up to the air leaving the regulator, going into the system, shuts the compressor down. All right. but yet the regulator is still open, so it's allowing air to bleed out of our 1 to 2 feet, a half-inch pipe tank now. Compressor starts up again because it drops pressure quickly. And so we get short cycling on the compressors. It's a bad thing because your customer is going to call you up and say, hey, your compressor is running all the time. It's making a lot of noises, all right? And over time, one of two things is going to happen unless you correct the situation. The regulator is going to get satisfied and it will shut down, then the compressor is going to stop running and short cycling, or the compressor is just going to flat out burn out. So not a good scenario. So what we want to do is we want to take that mechanical air maintenance device and just run that tankless compressor right into the dry system. All right, so let's look at another scenario where here's our ideal. We're checking all the boxes. We got a tank mounted compressor, a mechanical air maintenance device, and a new dry valve. All right, and in my scenario, we're in the worst case scenario business, so we're gonna look at this scenario, and let's say that compressor kicks on at 30 psi and kicks off at 40. So that means our tank pressure is maintained between 30 and 40, feeding into the air maintenance device, which is feeding the dry system. The monkey wrench here is you need to go and figure out where your switches are. You got to understand that electrical part of it. It's not just the electrical guy's pressure or problem, I should say that. Because in this case, what if our switch is set at 35 psi? All right, that means that you're going to get a low air supervisory signal before the compressor actually kicks on. Because if your compressor doesn't kick on till 30, your dry system is going to be at 30 before that compressor will kick on. So you're going to get that low air signal. So you got to make sure always your cut-in pressure's got to be higher than the low air switch setting. All right, so let's look at the other Model B electric pressure maintenance device. And it's a pressure maintenance device, but in reality, it's an air compressor controller. And it controls the on-off of the compressor. In the sole intent of this type of pressure maintenance device is to use with a Bare, B-A-R-E, not B-E-A-R, compressor. So basically a compressor with just the motor and the pump, no pressure switch of its own and no check valve. So it just takes air from the compressor and pushes it right into the system. So with that, there's always going to be a pressure range in your system. You're not going to have that constant pressure. So correct wiring, electrical stuff again. Here you go, Scott. Why are we talking about this? Remember, it's got to be a bare compressor. So this compressor in this example on the left does not have its own pressure switch. And you can see right above the Model B there, you've got an electrical panel. And that electrical panel's got to be wired into the pressure switch on the Model B. And then out of the Model B, then we go to the motor on the bare air compressor. So when we look at this scenario, hey, what's the deal? It's a tankless compressor. So what if it's got its own switch, right? So this is where the confusion starts. And this is a totally wrong installation. And yes, we've gotten these phone calls as well. But trust us, we're here to help. I don't mean that in a bad way. But the compressor, all right, that Model B air maintenance device cannot be used with a compressor with its own switch, because if you look in the, I've got an electrical feed going into the pressure switch on the Model B, and then I've got an electrical feed going into the pressure switch on the tankless compressor. It's not going to work. Only one switch can control the compressor. All right, so really what you can do is let's eliminate that Model B and just pump right into the system. All right, so speaking of that, let's get to that section, 82662, tankless compressors. All right, the requirement is, and the exception to the tank mounted compressor rule is, if you've got a system where you can fill it with a tankless compressor within your 30 minutes, you can do that, but your compressor is limited in size. It can't put out more than 5.5 cubic feet per minute at 10 psi. Why? Let's talk about it. All right, if you look out of the dry valve, we've got a single sprinkler operating with the little arrows there. All right, that small sprinkler can be a 2.8 K factor, but if we just talk about a dry system with a 5.6 K factor, which is the minimum, right, unless you use galvanized pipe, I've got just discharging out that single half-inch orifice. Now, if I put a tankless compressor on there that just feeds directly into the system and I oversize it, all right, I can push more air into the system than air that's leaving the system. So I can, in theory, keep my dry system from tripping until the compressor runs out of gas. All right, so that's the reason behind that. All right, so tankless compressors, just something else to consider. All right, and I already mentioned this, but the cut-in pressure must be higher than the minimum recommended pressure for your dry valve. Since it's not a constant pressure, there's a difference between your cut-in and your cut-out. So, if you look in one of our bulletins and it says, hey, I can maintain, 20 PSI in the system, all right, I've got a compressor here that I can buy it, maintain, cuts in at 20, cuts out at 26. So I'm overpressurizing a little bit, all right? But you always want to have that low end at your minimum recommended pressure. If you have that, if we recommend, if you got a high water pressure and we recommend 26 PSI in your system minimum, and you look at the bulletin, it says 26 PSI here, that's the cutout. More than likely, if you leave it that way, what's going to happen is before that compressor kicks in at 20 PSI, your system is tripped. So you need to pay attention to those settings and give us a call. We'll help you make those decisions. We'll help coach you, I'll say. All right. So ideal setup, automatic air maintenance. And flat out here it says black and white. Black and white is we're going to get in here. Each dry pipe system shall have a dedicated air maintenance device. All right, simply said, if you've got 3 dry valves on a manifold, each one of those dry valves has to have its own pressure maintenance device. You can't just do one and pipe to all 3 dry valves. Each one has to have its own pressure maintenance device. Clear as mud. All right, so if we go to the next slide here, if I push the right button, this is where, and this really did happen a couple weeks ago or last week when I was finishing up this presentation, and then the argument started. All right, let's go back a section or two and let's talk about unless the requirements of 82662 are met. All right, let's go down to 82662, where the air compressor supplying the dry pipe system, blah, 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 is less than 5.5 CFM at 10 PSI. So in theory, you could take a tankless compressor, have 3 valves manifolded like the picture shows, and feed each one of those systems. All right, as long as the largest system can be filled within 30 minutes and the compressor doesn't need to be oversized, more size larger than the 5.5 CFM limit. All right, the kicker there is you've got some other things you got to pay attention to, and we already touched on that in another section. You're required to have a check valve, checking off each system so you don't get air pressure sucked out of one system when another one trips, so a sympathy trip, or when a system trips, you don't get water flowing into the other system. Okay, so just an example, you've got the required check valve, you've got a shutoff valve in your air inlet here. All right, but let's go back to this because what if? Let's look at some pros and cons of doing it this way. I polled the group and everybody was consistent with, well, it's going to cost less money. All right, that's one pro. I threw an extra pro in there. You're going to get to see your customer more often. All right, why? Let's look at the cons. So let's look at the cons. You're going to have no air supply, no reserve air supply. So if you have a loss of power, power goes out in a storm or whatever, you have no reserve air supply. So if the system calls for air, it's going to keep dropping for air because there's no air to get. If your compressor just dies, you have no air supply, no reserve air supply. If you've got a tank mounted compressor, you've got a higher pressure tank there sitting there ready to throw air into your system. If there's a loss of power or if the compressor dies. All right, so we'll slow down the process. You have no flexibility with pressures. So if you have all 3 dry valves that are the same, all 3 require the same pressures, not as big a problem. But if you have several different systems, types of systems, what you're going to find is, those systems may require different pressures, and you do not have that adjustment. All right, and just flat out, we're just going to all tell you it's just a bad practice. All right, tank mounted compressor with 8 air maintenance devices on a manifolded system. All right, something new in the 2019 edition, electrical connections. If you've got a dedicated air compressor for your system, it can't be plugged into the wall or controlled with a light switch anymore. It's got to be hardwired into the panel. No ifs, ands, or buts, no exceptions to the rule anymore. All right, so Preaction Systems, when we look at that, basically the Preaction System section in NFPA 13 is going to refer you back to the dry pipe system air pressure and supply requirements. All right, so we've talked about air compressors. Let's talk about nitrogen supplies, because that's in NFPA 13 now too. I'm not going to read this all, but I'm going to just let this slide sit here for a second, and I'll let you soak up what that bottom section really says, focusing on maybe the last word in one of the lines there. But when you look at nitrogen supplies, basically you've got two choices. In reality, you've got nitrogen generators and then basically bottles of nitrogen. So with those options, at Reliable, we can we don't make any of those, but our sales guys can certainly help you out with that. And we'll certainly help answer some questions for you in our tech group. All right, so let's talk about bottled nitrogen, because NFPA addresses some special requirements for that. So if we take a bottle of nitrogen, all right, stored nitrogen, in other words, you've got a bottle that's sitting there, a brand new bottle is going to come in at about 2,400 PSI. All right, well, your system, none of your piping systems are going to handle that, so you've got to put a regulator on there similar to what you'd find on a gas welding system. All right, and you've got to regulate that pressure down to something manageable for your piping system. All right, another requirement NFPA says you've got to have a low pressure switch on that, because you've got to monitor the pressure in that bottle. It's a stored, you've got a limited amount, and when that pressure gets down to a certain point, just like a supervisory switch on your system, you need to get a notification, so hey, it's time to switch the bottle out. All right, and just keep in mind too, with a nitrogen tank, it's no different than a tank mounted air compressor. You need to add a mechanical air maintenance device to regulate it and limit the volume that's going to flow into your system. Okay, so if you don't want all that exposed piping and components, we actually make a device called the nsaSam. It's an automatic switchover and maintenance cabinet unit with all the internal components that will allow you to have, actually one bottle, two bottles, or a bottle and an air compressor backup. So you basically got a primary and a secondary source, and all the regulators you need, the supervisory switch, all in a closed cabinet. And just as a side note, the lights you see on the switch there are out of one of our valve trailers, and that's custom to the valve trailers. It's not available on the off-the-shelf ASAM units. All right, so supervision. The sprinkler guy's favorite subject, electricity. And this section is out of NFPA 72, and it applies to, basically all dry and pre-action systems that require supervisory pressure. And if you look at the three different sections, Section A, just basically across the board, that applies to all dry systems, all dry type systems. All right, Section B is intended to apply to differential dry valves, all right, because there's typically higher pressures in those. Section C is intended to apply to low pressure systems. All right, so the low pressure systems don't have as big a window, so they they'll refer back to what we recommend as a manufacturer for supervisory air pressures. All right, so then we talk about, we're in NFPA 72 again, and we look at the different supervisory switch options we actually utilize at Reliable. So we use the Potter PS25 for our low pressure systems. We use the PS40 for standard differential systems, and then the PS10 serves two purposes for us at Reliable. We use that, of course, on all of our systems for a water flow alarm. And then we also use it for a lower supervisory switch on our electric double interlock pre-actions. And that's simply because the actuation is all electric. There's no mechanical devices in the actuation trim that need a certain amount of air pressure to hold them closed. So with that, we can actually drop the pressure down to 10 PSI, between 7 and 10 PSI in those systems. So let's move on, and we're going to look under the cover. All right. Hopefully you've all seen this in a switch on the job site, but and you look at these and you'll see two sets of contacts there, and I'm just giving you a top view on purpose right now. But the -2 you typically see on the box, it just simply means there's two switches here, two internal switches. All right. Once again, somebody's out there asking, I'm a sprinkler guy, why do I need to know this? Well, it's really important that you understand what this switch is going to do on your system, all right? Because you, again, are going to be the one getting that phone call in the middle of the night. All right, so let's move on and let's look at this PS10, water flow switches. All right, if you look at the instructions come in the box, but there's also a label on these switches, and I've underlined here, PS10, I'm going to do a water flow switch. All right, that means I need to be wired to the common connection and then terminal 1. All right, and a water flow switch is a switch that sits normally with 0 pressure on the gauge, so under atmospheric air pressure. And it's a switch that when the valve trips, it energizes or charges the intermediate chamber alarm line. So it's a switch that activates on increasing pressure. All right. So let's just look at what happens when we do this. And this is my little, I came up with the term, and I didn't get this approved by Reliable, but I'm just gonna say this is the Redneck Reliable Lab, AKA my garage. All right, with this, I made a little contraption utilizing our LP pneumatic actuator, which is our pneumatic actuator. It's a low pressure pneumatic actuator we use on our DDX LP dry valves. All right, and so in reality, it's a miniature differential dry valve with a really high differential. All right, so you'll see on the bottom side, that's our supply pressure coming in. The top side is our system. So I've got 23 PSI air pressure maintained on that. I've got a low air switch on top set to go off at 18 PSI. And then on the right-hand side of that, I've got my alarm line with a water flow switch. And that's literally the discharge of the pneumatic actuator, all right? So keep in mind, atmospheric air pressure right now activates on increasing pressures. So if this works good, we'll click this and we're gonna get the little video going. And I've got lights on there. You'll see the low air go off and the water flow switch is active right now. Okay, so that's ideal. That's how it's supposed to work. So just out of curiosity, if this ever happened to any of you, right? What if we leave the wire on common, but if we move it and we wire it wrong and we connect it to the terminal 2 versus terminal 1? Well, what we do there, you know, it says right on that label, low pressure. Well, it's a DDXLP, Scott. That's a low pressure system, so that's where I have to put it. That's not what it means. It doesn't mean it's a low pressure system. It means it's a low pressure switch now, all right? So if we go back and take another look at the video, you can see that I've got my system is set up again, all right? My low air isn't active at 18. My system's sitting at 23. My supervisory pressure is at 23. My system is, I believe that gauge, if you could read it better, is going to sit about 55 PSI. And I have no pressure on the switch, and it's active. So let's see what happens when we trip our system and energize our alarm line. Ooh, we clear the alarm because we turned our water flow switch into a low pressure switch and we pressurized it, so this switch cleared. So that it's just wrong. All right, so moving on, let's look at the supervisory low air switches now. So if we look at the PS25 and the PS40 are going to be basically the same wiring here, okay? And we look at, now we're doing low pressure. So now we're at that COM N2, and you can see on the switch, the blown up picture there, you'll actually see it's low, all right? And a low air switch is a normally pressurized switch, and it activates on decreasing pressure. All right, so let's see how that's supposed to work just right. Once again, normally pressurized. We got 23 PSI in our system, and the switch is set to activate at 18. So if we drop pressure in the system, and you'll watch the gauge up there, you'll see it dropping. All right, once we pass that 18 mark, the switch is going to activate. I don't know what's going on with the video there, but basically it a little dancing action maybe. So that's the correct setup. All right. Once again, what if we wire it wrong? So now we turned our low air switch into a high air switch. So under lower normal pressures, we're not going to be active. All right. So let's look at this guy, and then I've got a question for you coming up here. All right. So look at the gauge on the system. Now we're under pressurized, okay? And my low air isn't going to activate until I replenish it, because now I've got a high air switch that's set at 18, okay? So what do you think? This ever happen to you guys? I bet it happens more than you want to know. We get these phone calls quite a bit, and what happens is you guys install the system, you guys install the switches, and all right, system's not ready to go, so you don't have it pressurized with air. You leave the job site, the electrician, alarm guy comes back, and I don't mean to pick on them, but it is always fun as a sprinkler guy. All right. Well, they come by and they wire up all the switches. All right. Well, the low air switch is a switch that is only going to be clear in a set up pressurized position, but there's no pressure on the system, so they wire it up and everything's clear on their panel. All right. You come back, you pressurize your system, you go into alarm just like this. Then we get the phone call, hey, you sold me a bad switch. All 5 of these switches on this manifold are bad. And that's not typically the problem, especially when you get more than one. It's most likely it's just the difference between changing the terminal on the switch from a 2 to a 1 or a 1 to a 2. All right, we'll help you with that. All right, so let's look at the high air pressure. We noted in NFPA 72 earlier that we do need to monitor that. Not all AHJs require that, but basically it's a high air switch is a normally pressurized switch that activates on increasing pressure. All right, so in this case, we've got to be COM and 1. All right, so let's look at the scenario here. We've got a system at 23 and the high air is set 28 PSI. We'll pressurize the system. Once we get too much pressure in the system, all right, we're going to get an activation. Is this important? It is. Too much pressure in your system can delay the operation of the valve trip, which can delay water getting to your fire, all right, after the sprinkler's open. So let's move on here. What if we wire it wrong? All right, you turn your high air switch into a low air switch. Okay, so let's look at this scenario here. System pressure, you can see there. Now we're over pressurized where we were an alarm when it was wired right. Now we're not an alarm until we drop pressure back to the normal. All right, so when we drop past that 28 PSI. And you can see the activation there. All right, so all that's said and done, you guys are, every system is not the same. Every system is different. You may have different pressures in your system, which means you may need to change the adjustment on your supervisory switch. And with that, I'm going to just say we'll help you with that if you have questions, but read the instructions. All right. And don't go hog wild when you're adjusting. Don't go 4 turns and expect it to be correct. Take baby steps, as Dave Ramsey would say on TV. So, and with that, let's talk about testing those switches. And there's devices out there called bleeder valves, and their intent is good. And I'm not saying they're bad, and they work really well probably on a differential system that has higher air pressures in it and a bigger window between trip point and low airs. All right, so on our low pressure systems, and that's our DDX valves, our DDX systems, we do not recommend the use of these bleeder valves because in reality, they may work too quick and trip your system because there is such a small window and you've got such a small volume of air actually sitting on your pneumatic actuator. So let's keep moving. All right, switch adjustment. And this is just a good example of how some of the ranges you can do with the switches. I've got 2 switches in this little movie here. So we've got the one on the right. It's my normal 18 PSI. You've seen it before today. And then on the far left there, I've got a switch that's set all the way down at 5 PSI. All right, so we get our first switch activation, and we'll kind of play some Jeopardy music here until we get that low air on the left-hand switch going. And when it down the other note there, it says follow manufacturer's instructions. That's not only the switches, but the valve manufacturer switch as well. All right. Reason for that is if we just back up with the camera and we go to the next video here, let's throw our little drive valve in there, and you can see the water flow pressure switch down there. And there's no light. You can see the red, but there's no light active, so it's not all is good. All right, so let's get going here. We're gonna have a sprinkler operate. System pressure is going to start dropping in that upper gauge. All right, we're going to get our normal low air at 18. We're not normally going to have 2 switches, but the example on the left there, that switch, let's see if that switch is set in a good spot. Oops. So in this case, and you saw the delayed reaction there, the switch wasn't set right. All right, so our valve tripped at 7, and the switch is low, our supervisory switch, which is going to give us that warning shot, is set at 5. All right, so note to self: always make sure your switches are set correctly for each individual system. All right, just make sure they're switched to give you a good amount of a little bit of a window anyway between your trip point and your low air alarm to hopefully get an alarm signal that's acknowledged versus ignored. All right, and almost last but not least, sometimes the best tools in your toolbox, just as simple as they can get. So if you take that bottle of water and throw a little dishwashing soap in there, that can solve a lot of your headaches if you're having problems with your airlines. So I am officially done. Here's our contact information, 1-800-557-2726. You can call us or text serve at reliablesprinkler.com. And I guess we open it up to questions. Wake up, everybody.
All right, thank you, Scott. We do have just a couple questions here. Surprisingly enough, either people did fall asleep or you did such a wonderful job explaining everything. The questions just were already answered. But first question.
I don't think that's possible. No.
Are restricted bypasses required on the terminology was non-tank mounted compressors, but let's rephrase: are restricted bypasses required on tankless compressors?
No, you can just pipe right into the system, but the criteria, that tankless compressor can't put out more than 5.5 CFM at 10 psi.
So, and in 13, if you read the actual language in there, it talks about two functions of air maintenance devices. One is to regulate pressure, and the other function is to actually restrict the amount of air that can get into the system for all the reasons that Scott has mentioned. So keep that in mind, that it's not always just about controlling pressure. It's actually right. Flow restriction, to make sure that the system operates like it should. Yep. Now, here's an interesting question. This could take a little bit longer, and I think this may have some.
Just only read the easy ones.
Does an air compressor need to be listed?
Oh, great question. And my favorite answer to a lot of things: that depends. Now, that depends on if you're just following straight NFPA 13 guidelines. Nope, it doesn't. NFPA does not require the compressor to be listed. Okay. However, there are jurisdictions across the country that do require the use of listed compressors, and they've got the trump card. Not getting political there, but they literally have a trump card where they can say, no, I'm going to require you to put a listed compressor in. In that case, you have to put a listed compressor in, otherwise no.
Yeah, and I think this is a subject of some debate in the committee meetings, and everyone has their own personal opinions on it. It is a very important part of the system, and a guy just kind of needs to do a quick ROI. In his own mind, as the contractor, as the guy who's responsible for it, to what level do you want to place the operational aspects of that system and the not having to go out there and take care of it. Do you want to spend a little extra money potentially for the UL listed model or not? And again, I think that just kind of falls into the best practice case, and different contractors will have different opinions on that. So,
absolutely. Go ahead.
No, you go ahead.
I was going to say, you're saving money. All right, I can go to, Kmart's not open anymore. I can go to Walmart, and buy an air compressor and put on my system, or I can go and I'm not endorsing, but I'm just saying that you could go to Reliable. Yes, I am endorsing. And buy a compressor, right? We've got a listed compressor. All right. You look at the components on that compressor compared to the one you buy at Walmart. Not a comparison. That one that you're going to buy from a reputable air compressor manufacturer, I'll say, is going to be built for that use. It's going to be built out of materials that are going to last more than 1 year and a day. All right. And trust me, I have experienced that as everybody, where you buy the cheap compressor and 9 months after you install it and walk away from the job, you're out there replacing the compressor. So now you bought 2 compressors, and in reality, you could have spent that money and bought 1 good compressor and not had to worry about it.
Yeah, and I always like to say that the first time that you make a trip to the job site that you don't get paid for a system that's just accidentally or had some other problem, you certainly could have afforded the better compressor. Last question that I see showing up here. I'm guessing it might be a friend of yours. I'm not going to name his name, but he wants to know if the fish are biting on Boy Lake.
I probably know who that is. And you know, the little northerns are. I'll say it that way. You know, they say there's walleyes in that lake, but I just, you know, I think those are pictures people have from years ago.
All right. Thank you, Scott. That's all for the questions that I see on there, and appreciate everyone's attention to the day, and we will see you here at Reliable in another 2 weeks with another webinar for your education and entertainment. Thank you, everyone.